Okay, so this video is going to look at factorising, and it is predominantly for foundation students. I'm going to look at the three different types of factorising questions that we might see on a foundation paper and talk you through the different examples. There'll be two examples on each. So the first one, I'm looking at factorising expression, and this is usually when we just have two terms. So if you have a look at example 1, we've got these two terms here, and in example 2 again, there are just two terms. It may be that you have a quadratic, or it may be that you have a cubic. Now, different people will teach this differently. I'm going to use the method of using the product to prime factors to try and make sure that we do get the highest common factor, because one of the problems that children sometimes do have is that they don't take out the highest common factor and therefore do not get all marks. This could be on a calculator or on a non-calculator paper, so I will show you both methods. So the first question I've got here is I want to factorise 5v plus 20w. If you remember, the word factorise means that we are putting it back into brackets. It is the inverse of multiplying out brackets, so at the end we can double check that we have got this correct. So I'm going to use product of prime factors method initially. I have just put down how we would do this on a calculator for those who might have forgotten. So I'm going to write 5v. Well, 5 is already a prime number, so actually there's nothing we can do with that. So I'm just going to write this out as 5 times by v. I'm going to do the same with 20w. So if I was using a calculator, I'd type 20 into the calculator, press equals, and then shift and the fact button. If it was non-calculator, I could do this by doing a product tree. So I could split that into 10 and 2. I'd circle the 2 because it is prime, and then again split the 10 into 5 and 2, of which both would be circled because they are prime numbers. So I'm going to write 20 as 2 multiplied by 2 multiplied by 5 multiplied by the w. To get the highest common factor, I'm looking for what is common in both. Well, 5 is in 5v and it is also in 20w. In this situation here, there is nothing else that is in both 5v and 20w, so 5 in this case is my highest common factor. That means 5 goes on the outside of my bracket. For the term 5v, I have v left over. For 20w, I'll have 2 times 2, which is 4, 4 times w, which will give me 4w. And that would be my final answer. As I said, you can double check this. So 5 times z would give me 5v, 5 times 4w would give me 20w. Second question, I'm going to do a very similar thing. So I've got 5x squared. We've already said that 5 is a prime number, so I'm going to write that as 5 multiplied through x and then multiplied by x again because it's x squared. Then have 10x, which is 2 times by 5 times by x. Again, we look to find the highest common factor, what is common in both of those terms. 5 is common in both, so I circle it. X is common in both, so again circled. That means my highest common factor is 5x. The highest common factor goes on the outside of your bracket, and then I have a look for each term. So 5x, we'll use the 5 and the x, so there is a single x left. This time I am subtracting. In 10x there is 2 left, so my answer is 5x, brackets x subtract 2. Double check, well 5x times x gives me 5x squared, and 5x subtract 2 would give me negative 10x, so I know those are correct. Okay, so we're now going to look at factorising a quadratic expression. Now, for those of you who I've taught, generally I do this by what I call the brick method, just so it's visual, and then I remember the difference between the different methods that I might need to use. So when we're talking about a quadratic expression, we're talking about when the highest power is a squared. So you will notice here that the highest power here is x squared. Now, it might not necessarily be x, it could be y, it could be a, it could be a different variable, but it doesn't matter, the method remains the same. So a quadratic, in these cases, generally have 3 terms. I'd have my x squared term, my x term, and then a constant, or what we call a coefficient on the end. So when I'm factorising, I want to put this back into what we call double brackets. Again, I can check it by multiplying out the bracket to check I've done the right thing. So I want two numbers that would multiply to make 24, but at the same time add to make 10. Now the way I play this into the bricks is I'm going to multiply to make 24, so that goes in the top brick. I'm going to add to make 10. Just going to write out the factors of 24 in pairs. So I could have 1 and 24. I could have 2 and 12. I could have 3 and 8, or I could have 4 and 6. So I've said I need to add to make 10. Well, this would give me 25, this would give me 14, this would give me 11, and this would give me 10. So the two numbers I'm interested in this case would be 4 and 6. Does not matter which way round we write them, that's absolutely fine. If I left the bricks and did nothing else in the exam, I wouldn't actually get any marks. So now I need to put it into brackets. So it would be x plus 4 and x plus 6. I could write it as x plus 6 and x plus 4. They are exactly the same. It doesn't matter which way round the pair, as long as they both have that positive sign. So example 2, the only difference now is actually I have negative 20, not positive. So remember, I'm going to multiply to make the number on the end, which is negative 20, and I'm going to add to make 8. So I'm going to write out the factors of 20 initially. So I could have 1 and 20, 2 times 10, and 4 times 5. However, this is negative 20, so that means that one of these numbers has to be negative to be able to give negative 20 when we multiply them together. So it could be negative 1, for example, and 20, or it could be 1 and negative 20. Same applies here. It could be negative 2 and 10, or it could be 2 and negative 10. It could be negative 4 and 5, or it could be 4 times negative 5. We need to add the pairs together, and we want to get 8. But if I add this together, give me 19. This would give me 8. This would give me 1. Give me negative 19. Give me negative 8. And give me negative 1. So the pair we need to use is negative 2 and positive 10. As we've just said, negative 2 times 10 gives me negative 20, and you can think of it as saying 10, take away 2 gives me 8. So this is the correct pair. Again, I need to put it back into brackets. So it'll be x subtract 2 and x add 10. If I'm asked to solve it when it's set equal to 0, I need to make sure I have my factorised brackets written down. Again, don't just leave them, please, in the brick diagram because you won't get the marks. I'm going to set that equal to 0. And the two solutions from this would be x is equal to positive 2 and x is equal to negative 10. The reason that being is, well, negative 10 as positive 10 will make 0. Positive 2 subtract 2 would make 0. And when two things are multiplied together to equal 0, either one or both of them must be 0. So final question here, we now have a negative on the end and a negative x term. So this time I'm going to multiply to make negative 18, and I am going to add to make negative 3. I'm going to write out my factors of 18, so it'll be 1 times 18, 2 times 9, 3 times 6. Because this is negative, one of them has to be negative. Just going to write them out as 1 times negative 18, 2 times negative 9, and 3 times negative 6. Add the pairs together. Well, this would give me 17, this would give me 7, this would give me positive 3, this would give me negative 17, this would give me negative 7. This pair here would give me negative 3, because negative 6 add 3 would give me negative 3. So I'd have 3 and negative 6. Then I put them back into brackets to be x add 3 and x subtract 6. If I'm asked to solve it when it's set equal to 0, again, just going to write down my solution from factorising, and then I'm going to write down my solutions from that. So x would be negative 3 and x would be positive 6. I did say before you could always double check this. I'm just going to change colour of my pen and show you. So if I wanted to double check that actually these two brackets here would multiply back out, if you remember, use a FOIL method, x times x is x squared. X times 6 will give me positive 6x. 4 times x will give me positive 4x. And 4 times 6 would give me 24. Add the x terms together, which gives me x squared plus 10x plus 24. So I can always double check that I have got that correct. So the final thing we're going to look at is the difference of 2 square. So these questions will only have 2 terms and both terms will be squared. There will always be a subtraction between the 2 terms. So if we have a look here, I've got x squared and 49. So x squared obviously is a squared term, it's a quadratic, and 49 is a squared number. Now I'm not sure if you remember how these work, so if I go back into the double brackets, I'm going to take the square root of x squared, which will give me x. Both brackets have opposite signs, so one's positive, one's negative, doesn't matter which way around it is. And then I take the square root of 49, which is 7, so it'll be plus 7, subtract 7. Now I'm just going to show you why this works. If I was to expand that bracket, x times x would give me x squared. X times negative 7 would give me negative 7x. 7 times x will give me positive 7x, and 7 times 7 will give me negative 49. You notice here the negative 7x plus 7x cancels to 0, so I'll get the answer of x squared subtract 49. If I have a look at the next one, so this time I've got x squared subtract 35 squared. So again, same principle. It's only a 1 mark question in an exam. Take the square root of x squared, which is x. Now this is 35 squared. So actually in this case here, one wants to be positive 35 and one wants to be negative 35. And that's all there is to it. The last one is a little bit more tricky. And again, this was a 1 mark question. And sometimes it'd be on a non-calculated paper and it would ask you to calculate 37 squared subtract 35 squared, which we're doing on a non-calculator, would take us a little bit of time. However, given they are both squared, we need to think about the difference of 2 squares. So 37 squared, if I take the square root of 37 squared, I just get 37. The subtraction sign, because they're both squared terms, one positive and one negative, and then take the square root of 35 squared, which is 35. Now what you'll notice that actually you can then do this calculation quite quickly. So if we added 37 and 35, that would give me an answer of 72. And I'm going to multiply that by 37, subtract 35, which is just 2. Well, 72 times 2 gives me an answer of 144. So I can factorise it quite quickly, and then from that notice that actually this is then becomes a really relatively straightforward calculation, rather than doing 37 times 37, calculating 35 times 35 and subtracting the 2, because as you can see, it's just a 1 mark question.